What's up, homies? My name is Iansh Kumar, and today I'll be demonstrating to you how to run my Retrieval Augmented Generation thing. So, first you have to install Python 3.1 and VS Code and all the prerequisites. Then you also have to install Ollama. Then you have to import these things. And then, after this, you must do this. Okay? You following along? And then check the env file to see what you like. So the URL path, which is where all the URLs to get the PDFs from are extracted, is urls.txt. The storage directory where it's stored on the computer is docs. The chunk size is 1200 characters. The chunk overlap is 200 characters. These are very... It's kind of fuzzy because of how the chunking works. Basically, it chunks at certain first priority things, which is the which is one empty line in between. Then it chunks at the space between lines, and then it chunks at a period, and then a comma. So the database directory which it goes to is ChromaDB, which is basically a vector database for searching up vectors close to another vector. The collection name is all documents. The model is Gemma3 4B-ITQAT, which you can get by, of course, installing Ollama and then putting in the command line. Well, not here, but like in the command line. Ollama pull Gemma3 4B-ITQAT. Of course, because I've already installed this, it is a success. So, and it's a very quick success. Okay, so basically the URLs we're using this with are NASA stuff, and basically we are using these questions. So let's go. So with this first line, we are importing ChromaDB iter tools for like quicker iteration and stuff, logging for logging, of course, PyMu PDF for reading PDFs, OS for doing things OS wide, and requests for getting stuff from websites. So we'll also be importing the recursive character text splitter, which is the chunking thing I was talking about from LangChain text splitters. We'll also be importing embedding functions for turning the chunks into vectors faster, and we'll import load.env so we can get our environment variables here, our precious environment variables. Is this running? Whatever. Whoo boy. Okay, so logging basic config, we basically have ingest log, write file mode, logging info, format with the time, the level, and the message, and the date format of hours, minutes, and seconds, and so you can verify. And of course, the logger is this, which I'm not sure what it means. So let's see what's happened so far. So we've loaded 20 URLs from urls.txt. We've initialized the collection. We've seen that the collection doesn't exist, so we've created it, and we've loaded the sentence transformer. We've downloaded and successfully saved these PDFs, all of these PDFs, and we're now processing the PDF and generating chunks from it. So basically this basically extracts the URLs from urls.txt. This gets the URL, the path, and the name of the file. If it already exists, then we're skipping download, or else we get it from the internet and successfully save it, or we fail document. Okay, so ingestion is complete, and it's complete in 56 plus 22. It is complete in 78 seconds. So, now we have the processor. Of course, here's some select defaults, but they don't matter because we've already enumerated the env, though you can change it if you want. So basically, for process PDF, it says that you're processing the PDF, and it yields the chunk of text, and then the information about that chunk, which is the name of the document, the page, the character count start, and the character count end. And then it says that it generated this many chunks from file name. And for vector store, it initializes the collection by trying to get and delete the collection, or else it logs an error, and then it creates the collection with the embedding function. And then it uploads batches of 2,000, separate one for each document, and then this is the thing that links it all together. Okay, that was long. So let's look at ask.py. First, gonna wait for it to chill a little bit, using the tried and tested method of lapping the laptop. Very dangerous. Do not try at home. Please, I don't want any lawsuits. What happened? I swear it worked last time. Oh well. So, now let's run ask.py. Okay, so looking at ask.py, we have some new things. Of course, similar logging. Okay, so let's see. We loaded the pre-trained sentence transformer and retrieved 6 chunks in 0.5 seconds. That doesn't matter because the big one is how quickly it generates the text. So we have the model. We have the system prompt. And it says that we have this model, of course. Then we try to link to this, which is the thing for Olama, and if I can't get it, it logs an error Olama offline. Then it gets the embedding model and stuff. And then it retrieves from the collection a query of 6 results, and it says that it retrieves this many chunks in a certain amount of time, and then it returns a dictionary version of this. Finally, it generates the text, and basically this is a long, complicated thing to get this to work optimally without burning up the computer. And getting lots of cool data, like tokens per second. Let's see. This spit out 16-ish tokens per second. Of course, this is partly because the computer is not doing so well. Okay, now for the citation processor. So you basically get the IDs, metadata, and documents. We get something to format the context for this, which is CTX. And then, to finalize, we use the regex to replace all of the chunk X things with a full citation, which is the PDF name, the page number, and the chunk, with .pdf, p dot, and chunk colon. And if it doesn't find that, then it just logs a hallucination as a warning. Oh, and the main thing, we basically initialize the rag searcher thing. And then we do a bunch of stuff, which basically, in summary, formats the text to look nice, and it links these things together. So let's see. It gave us a warning because chunk 8 is not in the results. But the token speed is looking pretty good. Yeah, actually, this overall is looking pretty good, surprisingly. Oh. Okay, so let's work out how many responses it's done. So it's done 1 response, 2 response, 3 response, 4 response, 5 response, 6 response, 7 response. So let's see what kind of responses it's given. What is the baseline in the context of these handbooks? An agreed to set of requirements, costs, schedules, designs, documents, etc. that will have changes controlled through formal approval and monitoring process. And that gives the citation. The expectation on products labeled baseline is that there will be at least final drafts going into the designated lifecycle review and baseline coming out of the lifecycle review. Within the project lifecycle, the baseline design is expected at or shortly before the end of the formulation phase, i.e. in time for a PDR. The approved current baseline defines the basis of the subsequent change. The functional baseline is established at the SDR by the NASA Programmer Project. Okay, so this isn't doing too badly, especially for something that can fit on my on 4 gigabytes. If you want a better one, you could get a bigger model like 12B, ITQAT, 27B, maybe 27B ITQAT if you're really well off. I mean, I do have enough for 27, but like, I'm not gonna wait that long. So basically, the structure is it's Q9. It gives the last amount of tokens per second, and then it says asks what is mentioned, and then it gives the question, and then there's the answer with all of the citations, and then the citations at the bottom. Now I could do a stream, but for now I'm not going to do it because the process of implementing something to replace the chunk mentions live would be a little complex. That said, I'm going to attempt to guess how long this will take. For one, it is already 11, which means that things shouldn't take too much longer. Anyway, so far it's taken approximately 6 minutes for 9 questions. Not too bad. Okay, now let's see the thing. This is for my GitHub. This has a lot of stuff. The git ignore doesn't commit the PyCache, the environments, the local storage. The secrets and local config. I would say the logs, but like it do it. Or the OS generated files. And of course the docs have all 10 documents. And ChromaDB has whatever this is. So while we wait for Q10, we're gonna see what kind of things it has. Damn, this is making me impatient.